All right, we are going to continue practicing graphing lines. We'll start with a warm-up to hone in our skills on some concepts we need to stay fresh on, and then we'll take a look at graphing lines. So to start this off, we're just going to work with some integers, starting with multiplying. We have a positive and a negative. So when we're multiplying, if our signs are different, our answer is going to be negative. If our signs are the same, our answer will be positive. So in this case, our signs are different. We will get a negative, and then I'm just multiplying 10 times 4 to get 40. So I'm doing my signs first with these, and then I am doing my operation, my math. So again, here I have same signs, a -2 and a -3. So when my signs are the same, when I'm multiplying, I'm going to get a positive answer. And then I do 2 times 3 to get 6. So positive 6. Okay, for this one, we are doing 24 divided by 6. These are both positive. My signs are the same, so I will get a positive answer. And I read this 24 divided by 6. So 24 divided by 6, which will give us 4. And then -24 divided by -3. This is a negative and a negative. So my signs are the same. It means my answer is going to be positive. So 24 divided by 3 will give us 8. Okay, number 5. This is a one-step equation. So on a one-step equation, I'm trying to get the variable, in this case x, by itself, which means I need to move whatever terms are on the same side of the equal sign with it. In this case, I need to move this 3. It is a positive 3. It is adding. So we do the inverse or the opposite operation. So the opposite of adding 3 is subtracting 3. So we are going to subtract 3 to both sides. These cancel out. 3 minus 3 is 0, so there are none of them. And then I'm going to bring my x down. So x equals, and then I need to follow my sign rules here. So for these are subtracting, or I'm sorry, these are the same sign, and we're adding and subtracting on this. So the same sign means we are going to add and then keep the sign. So we are going to add 3 plus 3 to make 6, and then keep the sign, which is negative. For number 6, this is a one-step equation. We have a -4 multiplying with n. Whenever we see a number sitting next to a variable, it means they are multiplying. So I need to get n by itself, which means that in blue, I need to move this -4 that's multiplying. In order to get rid of multiplication, we divide. So I'm going to divide by -4. And I show division by this fraction bar here. That means we're dividing. So I'm going to divide -4 to both sides. That makes these cancel out to give us 1n is equal to, and then I'm going to work this out. So same signs mean I'm going to get a positive number, and 36 divided by 4 will leave us with 9. So n equals positive 9. Okay, on this one, I need to get x by itself. It is being divided by 7 right now. It's being divided. This says x divided by 7. So in order to get rid of a number that is dividing, I need to multiply it to both sides. That cancels, a 7 that's multiplying cancels out or undoes a 7 that's dividing. And that means that x is now by itself. And then on this side, we are going to multiply this out. So we'll do 12 times 7, which is going to give us 84. Number 8, I need to get v by itself, and right now there is a -7 hanging out with it, a -7. So I need to get rid of this -7. What is the opposite of -7? It is +7. So the opposite of -7 is +7. So a -7 and a +7 cancel each other out. So V is now by itself, I'm going to write it down here, equals, and then I just work these out. 7 plus 1 is 8. So V equals 8. All right, couple quick two-step equations. For these, we're going to do what we just did up here on numbers 5, 6, 7, and 8, but we're going to do two things in one problem. So I need to move both the -3 and the 8 in order to get k by itself. So k is what I need to get alone. Right now it has a -3 hanging out with it, and that's multiplying. It has a -8 hanging out, and that is subtracting. So we always are going to move the term that is adding or subtracting first. That means we have to get rid of this -8 first. So we will add 8 to both sides because that's the opposite. That makes these cancel each other out. And then -3k is still here, so I'm just going to write it down. And then I'm going to work out -35 plus 8. We have different signs, so we are going to subtract and keep the sign of the larger number. So I'm going to subtract these and get 27, and then my larger number is negative, so I'm going to keep this -27. I'm going to keep talking through the sign rules because they're important to hear to begin to memorize what they are. So now I have a -3 multiplying with k. In order to undo multiplication, I have to divide. So I'm going to divide -3 to both sides. Just to back up for a second here, we could not add 3 to both sides because this is multiplying, and the way we undo multiplying is by dividing. This is addition, so adding 3 won't undo multiplying 3. So that's why we wouldn't add 3 to both sides. We actually need to divide -3 to both sides. That's going to make these cancel out. They become 1, and they leave us with 1k. You could write 1k, but it's not really necessary. It means the same thing. The same way that you would say, hand me my phone. You don't have to say, hand me my one phone. You would just say, hand me my phone. So yes, this is 1k, but it's also just k. And then I'm going to divide -27 divided by -3. My signs are the same, so it's going to give me a positive answer. And 27 divided by 3 is 9. So that's our answer there. And then this is our last one. So again, I need to get r by itself. I'm going to move my 6 first because I always move whatever is adding or subtracting first. And then I'll move whatever is multiplying or dividing. So I'll subtract 6. That makes these guys cancel each other out. R divided by 2 is left. I'm just rewriting it. And then 13 minus 6 is going to leave us with 7. Signs are different. Subtract, keep the sign of the larger number. And now, in order to get r by itself, r is being divided by 2. So what is the opposite of dividing? Multiplying. So we do the opposite. I multiply 2 to both sides, and that gets r by itself, and then we just work that out. 7 times 2 is 14. Okay, so I'm going to just continue to talk about y-intercept. We're going to talk about first the direction of the slope, and we are going to state the y-intercept. So when we're given an equation in slope-intercept form, This matches with the general formula, which is y equals mx plus b. And actually, I'm going to change the color on those. I'm going to make that black so that it kind of matches what we have. I'm going to get that out of the way. And then I'm going to highlight some things. So if you'll notice, y matches up there with my equation that I was given. M in blue matches to this value that's next to x. I'll use green. X in green, that matches. And then B, I'll use blue. B matches to my last term. So if I'm going to state my M, I will write M equals, and I'm going to write the stuff that's in blue, 5 over 2. I'm going to do this in black here. M equals 5 over 2. Oh, I used blue on both of these. I wasn't even paying attention. Let me change the colors here. That was my bad. Maybe I meant to use purple. There we go. So B is now in purple. So my M, I got that from the number next to my X. My B is my number at the end, which is 4. Okay, so that's the first part. If you can do that part easily, you are halfway done with having to graph. The other part of this is being able to tell our direction. So when we say M, which means the slope, M, it's just instead of writing slope every time, it's easier to write M. And in this case, our slope is 5 over 2. So our slope, we always talk about in terms of rise, which means to move up or down, over run, not pun, run, which means to move right or left. So in this case, if it's positive, we're going to move up and right. Let's take a look at number 12 and we'll continue working on this. So again, y equals mx plus b. My m and my b are right here. So my m equals 5, and I'm going to write it as a fraction so that I have both a rise and a run. My b is negative 4. And then I'm going to look, if I have a positive 5, I'm going to move up, and a positive 1, I move right. I've learned how to make this easy on you, which is we're always going to be moving right. So your bottom number is always going to be right, at least at first. So I'm doing blue. Here's my M, here's my B. Here's my M, 7 over 2. Here's my B. Oh, I'm still in purple, whatever. Or I'm still in blue. B is 2. And I'm using whatever sign's in front, positive 2. And then my M for my rise over run, this is positive, so it's going to go up, and I always go right. Okay, here's 14. M equals negative 5 over 2. B equals negative 1. So whenever we have a negative, it's going to mean we move down and right. We're always moving right. Okay, this one doesn't have a B. We could add it in here. If there's no number at the end, we could say plus 0. M equals 5 over 4. B equals 0. And then this is always right. We're always moving right. And then all we have to do is determine, are we going to go up or down here? It's positive. It's a positive number, so we're going to go up. Up 5, right 4. m equals negative 5 over 2. So that means we're going to go down and right. It's a negative. The negative means we go down. We're still always going to go right. b equals negative 3, and we're done. I'm going to move quickly through these because hopefully you're getting more and more familiar. And as I'm doing them, you're watching and going, oh, m is 3 over 5. B is negative 3. And we're going to go up 3, right 5. This will be the last one I do. I'm not going to do them all. M equals negative 3 over 5. B equals negative 3. And we're going to move down 3, right 5. Because there's a negative, we move down. When it's positive, we move up. So let's practice that with graphing. I'm going to label, I'm going to say m equals, b equals. So in this one, m equals negative 1 over 5, and b equals negative 2. And my m is telling me I'm going to move down and right. So everything over here is what we did up above. It's the same thing we were doing up here. The only difference is now there's a graph, and since we've labeled our m and our b, it's going to tell us how to plot our points. So b tells us where to begin, which means we start where we start. So we are going to begin at negative 2, and that's always on our y-axis. So that's always going up or down. We're going to count up or down to begin. So we go down 2, and then from this point, we are going to move down 1, right 5. And that would make a line like this. So we could move down and right. Now, if we run out of room, we are allowed to do the exact opposite. We could go up and left. Watch, I'm going to show you in purple. If I went up 1 and left 5, notice that my point is still on that line. So if we do the exact opposite, we still end up on the line. But it's much easier to always go up or down and then always go right, and then worry about changing it if you don't have enough graph room. Okay, here we go. I'll use blue again. M equals 2. That came from here. B equals negative 1. That came from here. Notice that I'm not writing the x. I'm not writing 2x. I'm just writing 2. And then I'll graph this in red. So B tells us where to begin, negative 1, and then move. Oh, well, I forgot to write what I'm supposed to do when I move. So if I jump into this and I realize I can make that a fraction, right? 2 over 1. And then this is telling me up and right. So I'm going to count up 2, 1, 2, and over 1. Up 2, right 1. Sorry, I created a little extra dot there. Shouldn't be there. So up 2, right 1. I'm going to make a line here. And what you'll notice, if I were to, I'll use orange, do the exact opposite. So if I were to go down and left instead, if I went down 2 and left 1, I can go down 2, left 1, and I'm still on that same line. So we can do one or the other. Okay, last couple here. M equals negative 3 over 1. I know I'm going to go down 3, right 1. B equals negative 2. So we begin at negative 2, and then I'm going to move down 3, 1, 2, 3, right 1. Oh, that made a circle. That was special. So again, I move down 1, 2, 3, and then right 1. And I can't go any further. If I try to go 3 more, I run out of graph. But I could do the exact opposite. I'll do that in orange. I could go up 3, left 1. So if I went 1, 2, 3, left 1, 1, 2, 3, left 1, and then I run out of graph 1, 2, 3, left 1. I'm kind of off of the graph there. But they end up being on the same line. Okay? And this is the last one I wanted to show you. So we don't have a b here. I'm going to add it in, plus 0. M equals 1 over 3. These are positive, so I'm going to go up and right. B equals 0. So I'm going to begin at 0 and then move up 1, right 3, and put a point. I can go up 1, right 3, put a point. I'm also allowed to do the exact opposite. I can go down 1, left 3, put a point. Same thing here. Okay, so for solving systems, this first unit, unit 1, it's really important that we understand how to graph lines, that we can graph them well, that we're really fluent, and that it doesn't take a lot of brain power to graph lines, because really the full part of this is just graphing 2 lines on one graph. So as long as we're really good at graphing one line on a graph, doing 2 is not a big deal. Okay?